We're now starting Chapter 5. In Chapter 5, we're going to investigate chemical reactions. The first thing I want you to know is that you do not need to read sections 5.5 and 5.6 on stoichiometry. We're not going to be doing stoichiometry in this course. However, we will be adding a little bit of new things on there that are not covered in the book on equilibrium, which is a very important area for people who are going into the biological sciences to understand. Now, chemical reactions are written all the time, and chemical reactions are incredibly important. Right now, inside your body, there are huge numbers of chemical reactions, billions and billions and billions occurring in order for you to live and function. When a chemical reaction occurs, what happens is you have old bonds break and new bonds form. An example shown below is methane and oxygen being combusted in order to make carbon dioxide and water. You can see that the old bonds between the oxygen and the carbon and hydrogens break so as to form new compounds. Remember, this is a time sequence. The reactants are present beforehand, the products are present afterwards. When looking at an equation, we must remember that the reactants are on the left and the products are on the right. And when a reaction occurs, the only thing that changes is the bonding between the atoms. So the number of atoms must be the same on either side. The coefficients tell us how many there are of the molecules. The subscripts tell us how many there are of each atom in the molecule. So every reaction that we write must have the same number of atoms on either side. We call this conservation of mass, and we call the process of making sure that the number of atoms does not change in a reaction. We call that mass balancing. In order to mass balance, we change the coefficients in the equation. We do not change the formulas. When you mass balance, you just need to make sure that the number of atoms on the reactant side is the same as the number of atoms of that element on the product side. And we only do that by changing the coefficients. As you can see, in this reaction, we have a coefficient of 2 in front of the oxygen, so that we have 4 oxygens on the reactant side. And we put a 2 in front of the water so that we make sure we have 4 hydrogens on the product side to match the 4 hydrogens on the reactant side, and 4 oxygens on the product side to match the 4 oxygens on the reactant side. When we write reactions, our symbols are pretty standard. An arrow, of course, it says a reaction is occurring. We use a little capital delta sign, a little triangle, to show heat. And then we will put after each compound an indication to say what state it's in: solid, liquid, gas, or aqueous, meaning it's dissolved in water. When we go to balance a reaction, what we must do is first write the equation with the correct formulas so that we have each substance written with a correct formula. Now, we never change the subscripts after we get the correct formulas written, because that changes what compound we have, and the compounds are specific to what happens in a reaction. To balance that reaction, what we do is we change the coefficients. We have a method of balancing reactions in which we never start with hydrogen and oxygen first, because those are the harder ones to balance. We usually start with the other elements. The first one that we will balance in this reaction will be carbon, because we want to do something besides hydrogen and oxygen. If I look on the left side of the equation, you will see that in the reactants we have 3 carbons. In order to make it so that the number of carbons is the same on the product side, we put a coefficient of 3 in front to say now that there are 3 entire carbon dioxides that are formed. Next, we're going to balance the hydrogens. To balance the hydrogens, we notice on this side we have 8, and on this side we only have 2. We put a 4 in front so that now we have 8 on this side. Next, we balance the oxygens. We count the oxygens on the reactant side and find 2, and then we count the oxygens that are on the product side, and we would find that there are 6 here and 4 here. Well, 2 and 6 plus 4, which is 10, do not match up, so to make it match, we put a 5 in front of the oxygen. As soon as you get through where you think your mass balanced in your reaction, you always want to go back and double check that all the elements are balanced, because what some people do is they end up changing the number of atoms of one element, and they don't realize it when they're changing the number of atoms of another. So always go back and check. Also make sure that you have the simplest ratio in your reaction. For instance, if you balance this reaction, you came up with a coefficient of 2 in front of the propane, 10 in front of the oxygen, 6 in front of the carbon dioxide, and 8 in front of the water, you would see they are all divisible by 2. So you would simplify it and divide by 2.